Hello everyone, this is Team Zebra Technologies with the AI ML Object Recognition and Analysis. So let's begin by introducing the Capstone Technical Directors, Matthew Corvasi and Patrick Haggerty. Next, we'll show the Capstone designers, James Hurtado, Corrali Coadio, and Ryan Steele. So who is Zebra Technologies? Zebra Technologies is a leading provider of printers, scanners, and other software solutions. As you can see below, we have 3 products and services, like the Personal Shopper, the ZQ630 Plus printer, and on-field tracking for the NFL. This project's motivation revolves around improving print quality for Zebra printers using a computer vision machine learning model. The model works by analyzing images of printouts, which will commonly be blurry or smudged, and will influence its decisions to change the printer's settings. As you can see below, there's an example of a blurry picture of a rose, which is then enhanced in quality. This simulates what occurs when we run our loop. For anticipated best outcomes, we've achieved them this semester. To begin, we have our hardware and setup, which involved a camera, a router, and printers. We had to get it all set up and working in tandem. Next, we had to choose our machine learning algorithm, our model, and tools. After that, we had to prepare an extensive data set and train the model for object detection with YOLO v5. After that, we had to deploy the model and our algorithm and use it. When it was used, it identified patterns and evaluated them, which influenced its decision to adjust the printer's settings and correct it. As for the economic impact of this project, artificial intelligence allows customers to run AI print tuning to test out new Zebra medias. In the past, this would have been done manually. Not only this, but engineers can focus on more projects as AI manages other processes. And lastly, there's quicker implementation. It serves as a tool and speeds up features. To give a brief overview of how the system works, the system begins by capturing an image of our initial printout. After that, it's sent to the machine learning model, which then analyzes the image and detects the printout. In short, it defines if it's a satisfying image or an unsatisfying image. And if it's unsatisfying, then the machine learning model needs to decide what printer setting to change. After that, it must change the setting and then reprint. It then captures another photo and does this until the image is satisfying. After that, the system is complete. So this is me, James Hurtado. I've been speaking, and I am mainly responsible for dataset creation as well as the machine learning model training and testing. So as far as the initial dataset creation, I began by creating a dataset of around 2,000 labels, and they look like how they were in this photo here. Object detection models require a large data set for training so that it can be accurate. And we can even expand upon this data set with augmentations. So in this example with the cats, we can see how our data set is multiplied in size. In this scenario, there's only one photo of a cat, which becomes 10 different photos as they're stretched, flipped, and tilted. This allows the machine learning model to not only have a larger data set, but also different scenarios in which the image occurs. After this occurs, we have to label the entire data set and annotate it so that the machine learning model knows what to look for. And lastly, I created the code to train and test the model. Thank you.
Hello, my name is Ryan Steele. I'm a computer engineering major with a minor in mathematics. For this project, I was in charge of hardware and network setup, wireless communication between the printer and our system, as well as software engineering and system integration. The 3 main hardware components for this project consisted of the Zebra ZQ620 printer, the Tomlov DM9 camera, which is actually a digital microscope, as well as the Netgear Nighthawk router. Initially, we used the Netgear Nighthawk router to establish a local network, which was then connected to the Zebra printer. Using the camera, we were able to take pictures of the label, which were then stored into a specific file, and they were then fed into our AI model. We programmed the Zebra printer using the Zebra toolbox, which we were able to change the settings to program an IP address and then connect it to the Wi-Fi network. Then we were able to use the Zebra programming language in our Python files to print specific labels. Initially, we had created a main Python file, which took care of the entire project all in one, It established a camera connection as well as the printer. It took in a user input for file paths, and it then fed the image into our model and received a little bit of feedback for tone adjustment. We decided that it would be a more professional approach to have multiple files. For an example, camera and printer connection, they each had their own file, and each file had its own task. We then implemented a configuration file, which would take in specific file paths and IP address for the printer. We thought that this would be a better approach because connecting the printer to the Wi-Fi was changing the IP address, so allowing the user to make a simple change in a configuration file allowed for easier production. Next will be Corrali.
My name is Corrali Coadio. I'm a computer engineering major, also double majoring in Japanese with a minor in mathematics. I was in charge of background researching, and I also worked on the parameter adjustment loop. In the fall, our main goal was researching machine learning models, and we could quickly establish how we wanted it to work. So first we sent the raw image for data augmentation to get more data and images to work with. Then it goes to pre-processing, which is the step where the raw data is transformed to be suitable for training machine learning models. Then it goes through our object detection model, post-processing, and then we get the final image, which is the detected object. During the spring semester, I'm mainly focused on developing a Python script for the parameter adjustment loop. So this is a simplified flowchart of the resulting code. So after the start, we take a picture, detect the object, and then we check if the quality is good. If it's good, then it's printed. We double check the quality of the print again. If we are satisfied with it, then the process is done. If we're not satisfied with it, we send it a comment to have the tone adjusted, and then we send it back again to take the picture and restart the process. So to break down further what is happening here, first, here are the initialization steps. So we start with the hardware setup. We initialize the hardware, check the camera settings, printer connection. Then from there in the code, the YOLO model, which is our machine learning model, is loaded, and we go on to capture the image. Then the next big step is in the printing process. So if an object is detected, that image is sent to pre-processing for printing, and two big things happen there. So first, we generate ZPL code, the Zebra programming language, which we use to communicate with the printer. So that's what we use to set the printer speed and darkness as necessary. And the other thing that happens here is that the detected object or image is converted into a 1-bit bitmap image. Basically, 1 bit per pixel represents each pixel with a single bit, as the name indicates. So whatever is detected will become a black and white image. So this is an advantage in machine learning training because those files are very small and they require minimal storage space. And also that small size facilitates the training of the smaller models. Lastly, this is something I was not able to implement, but I wanted to add to my code. It was the command line, basically having the option to enable a preview. So instead of printing every time we get an image, we could just have the preview and then check the quality that we wanted from there. If we were satisfied with it, then we send it to the printer. And then print it and check if it's the result that we wanted. If that is not the case, then we send it back all the way to the step where we check the object detection from the previous slide. So here is a summary of our team technical accomplishments. So for our project, we developed an object detection model, and this semester in particular, that dataset was improved and increased. We also increased the size. We have a functional tone adjustment loop, which is implemented with 7 different classifications for the type of printing setting that we want. And lastly, we also have a user interface now for the picture taking and live feed display of the images. Finally, we would like to express our sincere thanks to our technical directors, Matthew Corvese and Patrick Hergardi, also our consulting technical director, Jamie Gagnon, and finally, Dr. Harry Sunak. Thank you very much.